Good morning, mathematicians. We're back playing the lean game. Got one more level to get through in this problem set. And then I don't know. Do we keep up the momentum? Do I start a different learning series? I don't know. There's maybe yeah, hard to say. I do need to understand the vanishing cycles functor better. Um, so that's a possibility. Teaching myself the things I'm supposed to know. Good morning, Costa Kachori. But for now, we're doing analysis. So let's see. Get ourselves set up here. Okay. Determine the limit of the sequence 3n plus 8 over 2n plus 5. So I guess 3 over 2, right? If I divide everything by n and I take the limit, yeah. Okay, so there exists an L, so what do I use? 3 over 2. And then intro, the usual stuff. Okay. Now we actually have to do some math. Oh, you're looking into vanishing cycles recently. Apparently it originates in more topological contexts. Yeah. I mean, I've read plenty about it like that, but it just, when stuff just doesn't click, I just don't get it. And of course, I've done some computations with the vanishing cycles functor. I mean, I've got a paper that uses the fat features of the vanishing cycles functor with collaborators, but yeah, I don't know. I just need to understand it more deeply. It's tragic. I woke up super early this morning because of a leaky faucet in my bathroom making noise. That's a tragedy if I've ever heard one. Computations? What do you look like, an engineer? Well, you do have a little gear icon next to your name, so why is my background partly blue now? I'm not upset about it, but the background on this thing. Okay, what are we doing? It's 3n plus 8. 3n plus 8 over 2n plus 5. Was that what it was? I forget how to do these kinds of problems. We need to take like don't we take like a max of 2 of these or something? No, maybe not. What do I need? Let's see, epsilon 3n plus 8 less than 2n, epsilon plus 5, epsilon. No, I see. It's just this. So then we just need to do n. Wait, right? Yeah. But wait, I want n. How do I want to do this? So n less than, no, wait a second. How do I want to factor this? I want n by itself. Right, okay. So then I want 5 minus 5, 8 minus 5 epsilon over, well, hang on a second. Factor out, this is 2 epsilon minus 3. Seems like maybe a cases thing here, right? Because this will be negative for epsilon small. But I thought I ran into some issue trying to break things into cases before. I should be able to do a case-free version. Right. Well, maybe if I did like a max or something. Right, so... like if this is negative, then... what? Do I have cases? Do I have cases? Maybe make my life easier. But I could do... I don't think I have cases yet. Usually this is by expanding the fraction with 1 over n. So lower order terms diminish. I see. You mean like... how do you mean? How do you mean? Am I not missing a minus 3 over 2? Am I? Where? I go here. And I subtract 5 epsilon from both sides. I subtract 3n from both sides. That seems fine to me. But Rod, what are you suggesting I do? Expanding the fraction. So like if I looked at this like a... You mean if I take this out and then I call this... This is, what, 1 over 5, 2n over 5 plus 1. So I pull this over 5 out here, I guess. And then I use like a series expansion type thing. Is that what you're saying? What's x plus 1 or... Yeah. Yeah, that is what you're saying. Oh, wait. I see. Okay, wait. So we have 3n plus 8 over 5. No, 2n plus 5. And you're saying I should write it as 3 plus 8 over n over 2 plus 5 over n. Is that gonna help me? Oh, and then do the comparison to epsilon? Or what? Unrelated question. Don't ever apologize for that. We love unrelated questions here. Am I interested in model theory? You're just wondering since it has powerful tools for algebra problems. I don't use it for algebra problems. I'm not actually aware of the powerful... I'm not aware of the powerful tools available available to in model theory. Yeah. So I don't use it. Am I interested in it? Yeah. Like it would be nice to understand better model theory and to understand. I'd be interested to understand like logic and like different models of set theory and stuff. But yeah, there's only so many hours in a day, and I don't think it's likely I'll work on that anytime soon. Axe Grothendieck is a good example of that. Yeah. Yeah, I just don't. I just haven't particularly. I just haven't particularly made use of it yet. But I mean, maybe there's a good argument that I should be looking into it more. I don't know. Okay, Leo's got a model theory video coming. Great. I'll just watch that and then I'll be a pro. From baby's first limit, you can deduce that both of those go to 0. But I mean, so Arad, if we were simply doing, I mean, this would not have taken me this much time if we were simply trying to do real analysis, right? I mean, 100% I agree with you. The issue is that we're trying to do real analysis in lean. So, pushing limits in fractions, we don't have that. So, yeah, I'm not so sure. But maybe you're right in that using the 1 over, well, okay, but maybe we can use the theorems. Maybe we can, but we don't. I don't have temporary theorems. No theorems. No, it doesn't. I don't think we can use these. Yeah, I don't know if that's the right strategy. Oh, sorry. Of course, I'm being an idiot. I wrote the wrong thing. I wrote the wrong thing. Yeah, exactly. Yeah. I wrote the wrong thing. You're exactly right, Danica. Thanks. But also, actually, is this series, or sorry, is this sequence, is it bigger than 3 over 2? For, like, is that minus 3 over 2 going to be positive? Yes, right? Surely. Well, no, I don't know. Is it? I'm gonna go over. Hang on. Call me crazy, but I'm gonna go over to Desmos for a second. I don't want to log in. What is this? What is this bullshit? Log in. 3x plus 8 over 2x plus 5. And then let's just put y equals 3 over 2. It does look like it's bigger. Yeah, okay, good. But we're going to need to prove that as well, which shouldn't be hard, but maybe tedious. Nice. It's always a good day when you used Desmos a non-trivial amount of time. You know, my one graph theory paper, I actually used Desmos a lot as I was finding, like, as I was trying to find certain ways to bound these certain functions that appear in the paper. I used Desmos a lot. It was great. Um, okay. Oh, you'd simplify to making that go to 0? But do we even have additivity of limits in this game? Like, do we even have additivity of limits? I don't know. By Desmos, yeah. When can Desmos be imported? Okay, so yes. Okay, so let's write things out not incorrectly. Notice I was careful to not say correctly. I don't take law of excluded middle for granted around here. If I simplify that, I get that, which can be shown to be less than e positive e. Yeah. What about medium length division? You know, everyone forgets about that one. How old am I? I look like your high school math teacher. Well, how old are you? Because that either, I don't know if that makes me look old or not. I mean, probably. Probably you're saying I'm unked up. Yeah, I'm about 80. Give me a second here. I mean, how old are like the youngest how old are the youngest high school teachers? Like um yeah, how old are the youngest high school teachers? When would you start teaching? 24, 23? No, let's say 18, 4 years. Yeah, 22, 23. Oh, you're 18. Okay. Yeah, so you probably think your high school teacher is ancient. Uh, I must be a decrepit old man to you in comparison. Wait, are you, Danny, are you just saying if you simplify, you get 1 over. Really? Really? It'll. Is that so? Okay. Okay. Minus 15. It doesn't look like that's what. Wait, what the hell am I doing? Oh, yeah. I want 3 times that. No, and then, sorry, this should be 6. And this should be 16. Oh, nice. I see. Okay, you're right. It does cancel out nicely. Okay. 2n plus 5. Right. 1 over 2n plus 5 less than epsilon. Nice. Okay. So then, yeah, what do we want? We want epsilon inverse less than over 2n plus 5 minus 5 over 2, right? That's the n that we want. That's the n that we want. Epsilon inverse over 2 minus 5 over 2. Is that right? Let me just double check my math here. Epsilon inverse divided by 2 minus 5 divided by 2 again. Yeah. I guess I could do epsilon inverse over 4 minus 5 over 2. Mind you, well, whatever, at the end of it, I'll just field simp it until I have enough. Maybe I'll write it like this. I'll write it like this. You love when the numbers just do the number, yeah, and make number, yeah. It's always my favorite part. You can do this with any 2 polynomials, huh? I can always do what? Make the numbers number? Oh, man. Oh, I spilled some coffee on my writing pad. Worth knowing for computation, complex analysis problems. Okay. Right. So what am I doing here? Now I need to choose n. How did we write this last time? I have no memory. Choose n, hn. And then, okay, arch prop. But I want to use arch prop on a different thing, right? So have bound, I don't know, maybe I'll call it have bound, wait a second. Intro, have A2 by arch prop on A1. Right, so I'm going to need a claim that this whole thing is bigger than, wait a second. No, that's fine. I just need to define a quantity, right? Right, so have, okay, so we could go have bound, which is arch prop. Well, no, I think I need to be able to take the inverse. Right? If I want to take 1 over epsilon, the argument, I somehow need to feed the argument the fact that, like if I was going to define something using 1 over epsilon, probably it wants me to feed in the fact that epsilon's greater than 0. But okay, let me just see what happens. So let me go epsilon inverse over 2 minus 5. Yeah, so yeah, I think it's unhappy because like I need to somehow justify first that I can divide, that I can take 1 over epsilon, right? So maybe how do I just define this shouldn't be that tricky, right? How do I just define a term to be that Oh, yeah, I need a thing bigger than 0. Wait a second, but I do have theorems. I proved a more general version of arch prop, right? So this one takes an epsilon bigger than 0. My epsilon may not be bigger than 0. But didn't we prove in a previous exercise? I thought we proved a generalization of arch prop. I thought we proved a generalization of arch prop in a previous exercise. Can I appeal to that? Your audio isn't working, so you'll just leave it at saying hello. Well, hello. Yeah, where was our more general? You hope my new job, a TT, tenure track. Well, I'm applying for postdoc, so I will not be getting a tenure track. Will enable me to not have to stay in a clothing closet. Well, I think if I do end up in a gold-plated, diamond ornamented King Hall, that will be because I didn't get a postdoc and I went to industry instead. That's probably it. Okay, where did we... Where was ArchProp? I wish there was an easy way to just search through all of these. Yeah, I probably... Yeah, the thing is I probably can't even though we proved a stronger ArchProp, I probably can't even call on it here, right? Yeah, maybe it's not in this problem set. No. Okay, I don't think it's gonna be in here. Problem set 2? No. More fun with sequences? Okay. No, this was proving ArchProp. Right, so is there... I swear we did a more general version, right? But, right, I think we can take absolute values, though. I think we can take absolute values. So maybe that's how we get away with it. Right, maybe we take the absolute value of this thing. Okay. Okay. But we still need... Yeah, I'm also very sure we had a general ArchProp, but I'm just not so sure we can use it. But we can use the absolute value. And but the point is, but we still need to justify being able to... Right, okay. What am I going to do? Have... I don't know. Have... term. Which will be this thing over 2 absolute value. Well, we don't know if it's 0 or not. Because this could turn out... This could be 0, technically. I'm glad to see that you called me by my full true name here. You know, the rest of you in chat should be oh, I can drop the -5. That's true. That's true, actually. Okay, let me go back and do that. But yeah, the rest of you should be referring to me as my full name like this. They better have a helipad prepared for the roof. Yeah. Yeah. Postdoc offices are actually offices, just small and shared. Yeah. King theory. Exactly. Don't forget it. That's what the K stands for. No, I know that won't be bigger than 0. That's why I was taking the absolute value. But yeah, let's go back here for a second. True. So what do we need? Wait a second. Right. Right. Where are we here? we just need, we have epsilon inverse over 2n plus 5. Right. So this is less than this, and so it would suffice to get 2n bigger than this thing. So we could take epsilon inverse over 4. Okay, great. 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 So have epsilon inverse bigger than 0. Why didn't it... is that right? Why doesn't that look right? There we go. Have epsilon inverse bigger than 0 by bound or something, right? K is for class in German. Yeah. Time for king theory class. Yeah, a swing and a miss, Leo. A swing and a miss over here. What did I calculate this expression again for? Who knows? Who knows? I don't even remember anymore. Kristaps is for king, but something in kingish. Yeah, what's wrong about this? Invalid pattern. Would I want something like this? Yeah, there we go. Okay. Could I even just pop that bad boy in there? Yeah. Have, I don't know. I'll call it A. And then I can arch prop on A. Right. Something's, yeah. And then I could do, what is it? Choose N, H, N. Choose N, H, N. Using, what is it? Choose N, H, N using bound. And we are off to the races. No, didn't like that. Didn't like that. Oh, no, it's... No, yeah, we're good. Okay. It's crazy. Growth Indeed got Growth Indeed group construction, even though it's like literally how we go from N to Z. Yeah. Yeah, but it's a more fancy way. It's a more fancy way. Yeah. Okay. How are we for time here? 33 minutes, yeah. I might call it here. I think we did the hard part. Tomorrow's the easy part. And by the easy part, probably it'll be long and technical. So, well, construction may not be very deep, but, you know, don't you remember this famous quote of Grothendieck? Where he said the concept of zero and the concept of groups were general nonsense too, and mathematics stagnated for 1,000 years because no one was around to take such childish steps. So, watch it take 400 new halves. Yeah, this is probably going to be a lot of halves. Actually, I don't know. Maybe it won't be that bad. But, wait, use N. Let me do that one, right? That's the next one. Boom. Use N intro. Okay, now we're set up to intro to do some real work tomorrow. So I will see. Oh, I see. A is called the sequence, so I should not have called this. Maybe I'll call it B, and then I'll call this thing B, and then the rest should go through just fine. Okay. 0 might be the biggest leap in all of mathematics. Yeah, that's true. Okay. Yeah. Q, E, D.